Hello, I'm Mr. Powell, and we're here to talk about the basic fundamental workings of the computer. The computer system. The computer system is said to have two parts. Those parts are hardware and software. Hardware are the physical parts of the computer that we can touch: the monitor, the case, the system board, the keyboard, mouse. The software are the instructions that the computer uses to perform work. And technically, it's not only the instructions, but also the data that's worked on by the instructions are in working memory, and they make up the software. There's two kinds of software, two kinds of data. And we'll talk about that in just a little bit. Right now we want to concentrate on the 5 types of hardware that are involved in the system. Let me draw a diagram here. There's really sometimes 6 parts, but there's 5 parts to a closed system. The 6th part is talked about in many texts as communication devices, and so that's outside the system, and so that's a 6th part of hardware, are those devices needed to communicate. But we're going to keep in a closed system here. Here's a basic mainframe model chart. This looks a little different in certain texts. Some texts will rearrange these same 5 parts to be in a little different order, but this is our basic mainframe model. This is our input devices. This is our output devices, because we're talking about hardware. Examples of input devices would be our basic 101 keyboard. We have our 10 key, our keyboard proper, our cursor control. Another device would be our mouse. A mouse is a pointing device. Other pointing devices would be a joystick, a trackball. Another input device would be a microphone. Another input device would be our webcam. Maybe a little shade of Howl going on there. Okay. We use our webcam, our microphone, our pointing devices, our keyboard, a flatbed scanner might be another example of an input device. That might be a little hard to see there. But we have a flatbed scanner that would fax a facsimile as input, as an input device. These input devices, well, get stuff into the computer, usually manipulated in the computer, and then it's outputted through other devices. Example of an output device might be the screen that you're looking at right now. That's your monitor. Another output device would be the printer. Okay? If you print it out on a piece of paper, it's said to be hard copy. If it's kept in the system and you view it on the monitor, it's said to be soft copy. Other output device example would be your speakers. Similarly, you'd have headphones and earbuds as output devices. We input to RAM, random access memory, sometimes called working memory, because this is where we put things while we work on them and manipulate them during processing before we output them. We call it addressable memory because there's little tiny cubby holes here where there's an address, and we put information into that address of memory, and we retrieve the information from that address of memory. Next we have the CPU, Central Processing Unit. The Central Processing Unit is made up of many parts. We're just going to talk about the two major parts. Two major parts would be the arithmetic logic unit and the control. Control. Arithmetic logic unit made up of two major parts. The arithmetic part that does math, addition, subtraction, multiplication, division, and the logic part that does comparisons. Can compare two numbers to each other. This is 10 or 2, whichever you want to look at, decimal or binary. Say, does this number equals this number? And returns an example of yes or no. Is this number greater than this number? Yes, no. Is this number less than this number? This would return a value of yes. This would return a value of no. This would return a value of no. We can do combinations of these using and, or, XOR, not. But the logic happens here. In the hands of a programmer, this logic unit has the computer appear to be thinking. But it's not. It's only drawing comparisons. The control manages the resources of the computer. Manages not only all the input devices, the output devices, but the allocation of memory and storage, and controls the fetch cycle, where we bring in information from RAM. We bring it into the CPU, and we retrieve it. We call it fetch, decode, execute, and store the results in memory. The control manages all of that. Control, arithmetic, logic unit are the two main portions of the CPU. Final portion is the store. Okay? The store is where we store information, programs and data, that is not currently being processed with the interaction of RAM and the CPU. We have three major storage devices, types of devices that we use. We have magnetic devices, where we use a little electromagnet to put a spot on concentric circles of our platter. So we say spot, no spot, spot, no spot, 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 no spot. And these corresponding spots that we have on our hard drive relate to open and close switches, or ones and zeros in our working memory. So we can do that magnetically on our hard drive or on a floppy drive. And so I'm going to draw our little magnetic concentric circles right there. And we have another storage device, is an optical disc, like our compact disc. Our compact disc, uses light or laser beams. We use a laser beam to write, and if we shoot a little laser beam in here, we put a little pit on the smooth surfaces. And if you put a pit there, that could be like a 1, and when there's no pit, we call that a LAN, and that would be a 0. Sometimes we reverse that if it's a negative or positive CD. We have our CD there. We have another laser beam that we shoot on there. Boom! We shoot it on here. If it bounces back, it's a 1. If it doesn't bounce back, it's a 0. Or so on. Either way, we are showing 1s or 0s, or open or closed gates that correspond to off-and-on switches in our RAM. That's storage. So we are using a storage device, and we're using optics for that, and that's our CD, or our optical discs. We have another type of storage device, and that's a solid state. Sometimes using our USB drive is an example of solid state, or an SD RAM, or mini SD, micro SD. All of them are storage devices, but they're solid state storage devices, to where we put information on, we remove them from power, the information is still there. We call that being non-volatile. Two parts to this. Storage devices are all non-volatile. Two parts we're looking at, power and status. So power, we lose power, the information remains. That's considered non-volatile. So we can put an example here of a USB drive. Okay. So, to recap, we have the 5 categories of hardware devices. We have our input devices, we have our output devices, we have our RAM memory, storage memory, or we have our RAM memory, our storage memory, and our CPU. Okay? Our RAM memory is considered to be volatile memory. That means when we lose power, it forgets. Again, our storage memory, when we lose power, it remains. So volatile memory, storage, non-volatile memory. And then we have the program processing cycle. The program processing cycle is input, processing, output, store. And that's what programmers do all day long. Input, processing, output, store. You can input your document, change the format, print it out, store the letter for later use. Whatever it is, the program processing cycle is input, processing, output, store. Examples of input devices: webcam, microphone, scanner, mouse, keyboard. Examples of output devices: monitor, printer, speakers. Examples of storage devices: we have our magnetic, we have our optical, and our solid state. These are the basic parts of our computer hardware. Thank you very much.